Okay, so today we're going to start on triangles. Now, you should know a little bit of information about triangles already. So, triangles are closed figures with three straight sides and three angles. Now, remember like tricycle, there's three wheels. And that's where the tri part comes with triangles. We have three angles. So, we have two ways that we like to classify triangles. The first way is by sides, and you should already know some information about this. We have scaling, which means that no sides are congruent. So all three of these sides on this triangle are all different lengths. The next one is isosceles, which we have two sides congruent. Now, don't forget we use these little tick marks right here to show that we have segments that are congruent. And we also have equilateral. Equilateral looks like equal. That means that all three sides are congruent. So all three side lengths have equal measure. That's why I marked them all with the same congruent mark. Now, the other way we like to classify them is by angles. We have acute triangles, which means that all three angles are acute, so all three angles are less than 90 degrees. We have obtuse triangles, where we have one angle that is obtuse, and obtuse means we have greater than 180 degrees. If you look right here, this angle appears to be obtuse. The next way is, the next type is a right triangle, which means that one of our angles is right. And remember, we use that little square in the corner to say that an angle is right. It's 90 degrees. And then the last type is equiangular. Now, it literally means equal angles. So all angles are congruent. Now, the way we mark angles congruent are these like little rainbow marks. Right here, and right here. And since they all have the same number of rainbow marks, these angles are all congruent. Now, the cool thing about equiangular is the same thing as equilateral. If you have a triangle where all three angles are congruent, also all three sides are congruent. Okay, so the way we name them is they're named by the 3 points and this little triangle symbol right here. So here's a little example. I've got a triangle drawn, and this is how we write it. We write the little triangle symbol, LMN, and we just say that as triangle LMN. So here's our first example. It says, identify the indicated type of triangle in the picture. Now we only have to do one. There's a couple of right, obtuse, and isosceles triangles in here, but we only have to do one. So first, let's find a right triangle. So we want to look for triangles that have the little squares for one of the angles. And if you see, we've got 1, 2, 3, 4. So we got a lot of right triangles in here. So I'm just going to start with, let's just do this triangle right here. Right there. Because if you see, we've got this angle right here. So I'm going to say we have triangle, and we just need to name the 3 points. It doesn't matter what order. I'm going to say BCD. Triangle BCD. So there's a right triangle in our picture. Now an obtuse triangle, let's see. If you look, this big triangle right here looks like it's obtuse. From this angle B right here, it looks like we have a big angle here. So let's say we are going to write that as triangle ABE. And then we need to find an isosceles triangle. So we're trying to find a triangle that has two sides that are congruent. And remember, we're going to use the little tick marks. Now, we've got a couple of them in here. My eyes just go to this one right here. Now, we know this one's isosceles because we have this and this marked congruent. So I'm going to write triangle ECD. Triangle ECD is isosceles. So, the first thing we need to talk about in triangles is the most important thing. It's called the angle-sum theorem. This is very, very important. A theorem is a statement that has been proven true. So somebody back in time, probably Euclid, proved the angle-sum theorem. Now, the angle-sum theorem says that The sum of the measures of interior angles of any triangle is 180 degrees. Now, sum means that we're going to add together all the measures of all of the interior angles. So, the measure of angle x plus the measure of angle y plus the measure of angle z equals 180 in this particular example. That goes for any triangle, doesn't matter what type. We're always going to have the angles on the inside sum to 180 degrees. Very important. So, now when we're starting to do these examples, don't forget about what you talked about yesterday. Vertical angles, how they're always congruent. Remember, they're across from each other at an intersection. Boom and boom. And also supplementary angles that add to 180 and complementary angles that add to 90. Okay, so let's start an example. So example 2 says, use the picture to find the measures of. So let's take a look at our picture first. We got a lot of things going on here. We've got a bunch of different triangles, and we also have things backed up to lines, which means that we're going to have some supplementary angles. So let's talk about the first part, A. A says find the measure of angle 1. So here's 1. Now, what we do know is that this angle, the 47, the 69, and angle 1 all back up to this line right here, which means that they are going to be supplementary. So 47 plus 69 plus whatever the measure of angle 1 is going to be 180 degrees. So let's write that. So we're going to have 47 plus 69 plus the measure of angle 1 is equal to 180 degrees. So all we have to do is add 47 and 69 and subtract it from 180. And you get 64 degrees. So the measure of angle 1, is 64. I'm going to kind of write it in here on my picture so I can use that information for the next part. So it says now to find the measure of angle 2. Now the measure of angle 2 is part of this triangle right here. So if you are ever faced with a situation where you've got two angles of a triangle and you're only missing one, you can use your angle sum theorem. So angle 2 plus 63 plus 64 is all going to add to 180 degrees. So let's write that. So we have 63 plus 64 plus the measure of angle 2 is going to give me 180 degrees. So all you have to do is add 64 and 63, or 63 and 64, and subtract it from 180 degrees. And you get 53 degrees. So that's the measure of angle 2. I'm going to write it on my picture. I might need it, I might not. Okay, so now let's find the measure of angle 3. Now if you take a look at angle 3, which is right here, we can use the fact that from here to here we have a straight line. So angle 3 and the 64 degree angle are supplementary angles. So they're going to sum to 180 degrees. So 64 plus the measure of angle 3 would give me 180 degrees. So literally, I could take 180 and subtract 64 from it, and I know that the measure of angle 3 is 116 degrees. So I'm going to write that on my picture. Okay, so the next one says we need to find the measure of angle 4. Now, similar to number 2, we've got a triangle here. Take a look at this triangle. We have two of the angles. We have the 32 degree angle and the 116 degree angle. Remember, if you've got a triangle and you know two of the angles and you're missing one, you can use your angle sum theorem. So we know that 32 plus 116 plus whatever the measure of angle 4 is going to give me 180. So if you add 32 plus 116 and you subtract that from 180, for angle 4 you get 32 degrees. Now let's look at angle 5. Let me mark this one up here. 32 degrees. Might not need it, but you never know. So next we got to do is find the measure of angle 5. Angle 5 is over here. Now, similar to where we found the measure of angle 3, so C, we have a line here, which means that these two angles, 5 and 136, are supplementary. So what we need to do is we know that 136 plus the measure of angle 5 is going to give me 180 degrees. So if you subtract 136 from both sides, you get that the measure of angle 5 is 44 degrees. And the last thing we got to find is the measure of angle 6. So we've got another triangle here. We've got this triangle right here. So we know that 47 plus 44 plus whatever the measure of angle 6 is going to be 180 degrees based on your angle sum theorem. So we can say 47 plus 44 plus the measure of angle 6 would give me 180 degrees. So if you add 47 and 44 and subtract it from 180, you get 89 degrees for the measure of angle 6. Now, we didn't use complementary angles in this, and we didn't use vertical angles in this, but you need to be on the lookout for them.